AI got really, really good at classifying and, to some degree, localizing objects in an image, like here. And despite all this progress, it stayed really, really bad for a very long time, pretty much till now, at really understanding what's going on in front of the camera as scene unfolds in real time. Understanding that a person just entered the room, for example, is completely trivial for humans. And the reason for that is that humans have a whole lot of common sense knowledge about the physical world that machines don't easily have if they're trained to, like draw bounding boxes around cats and dogs and so on. The kind of knowledge that humans have from, growing up as a child, playing around with objects and so on, are things like other humans are objects. They are three-dimensional. They are immersed in a three-dimensional world. I'm in a three-dimensional world as well. They're surrounded by air. They can move from one place to the other, sometimes themselves if they're humans. They cannot move through doors that are closed, but they can move through a door after opening it or something. There are some objects that are transparent, like glass windows and stuff. Even though I see something behind a glass window, it doesn't mean it's here in the room with me, etc., etc. What we have done at 20 Billion Neurons, a company that I helped co-found some 3 years ago, is to essentially build a box. For which you see a 3D printed self-made prototype on the left, and a little version of it underneath the screen over there. It's roughly this size. And so what this box does is the following. It's very simple. You hook up a camera on one side. You hook up a subscriber, some kind of computer system on the other side. And then it just sucks in the video from the RGB consumer camera that you hooked up to it and tries to understand what's going on in front of the camera as it's watching. What you're going to see here is a demo. This was the very, very first demo that we ever produced using this kind of system. It's running at like quadruple speed or something. So let me go through this in the short time that this talk is going to last. And so all it does is it tries to tell you in blue what it thinks just happened, what it just looked at, what just happened in front of it. And what the things that it does recognize range from stuff that can happen to objects. It understands certain occlusion patterns and stuff like that, motion patterns. It also understands certain hand gestures and ways in which humans can move around in a domestic scene and so on. And it can understand basically where somebody is and what the person is doing and so on. There's no funky IoT device sitting behind this or something like that. All this is a simple neural net that's reading in the RGB camera stream and just describing the scene as it unfolds. There's also no depth sensor. There's no other sensor. There's no multiple cameras or something. It's just one simple RGB camera hooked up to this box, and that's it. There are a couple of things driving this solution internally. The starting point, obviously, is a gigantic database of videos that we use to train these neural networks. We have created, over the course of the last 2.5 years, essentially a movie studio that has many, many thousands of actors all around the world that film themselves in response to instructions that we provide. And these instructions are there to make sure that we get videos that are good at instilling some kind of common sense in these systems so they understand what objects are implicitly. They understand where they moved, what they're doing, and so on, without having to explicitly say, this is a cat, this is a dog over there, or something like that. That's the starting point, is data generation. From there, obviously, we train neural networks. Then there's real-time engineering that makes sure that this is a system that can run on various kinds of chip architectures and so on in real time to run, say, on safe cell phones and various things. And then on top of that, there's a solution such that a person can actually use it and play with it and so on. Typically, when you start building such a system, you get to the solution and then the whole thing breaks because you realize that there are certain classes this thing cannot recognize properly, or a person interacting with this new kind of technology, actually using it, using gestures to control a device or something, behaves in a weird, unexpected way, using a certain pose in order to do these gestures, etc. And so that's where the feedback cycle gets into play. And so what's really happening is we start with an early ref or point 1 of this system. We explore how users interact with it, and then we see how it doesn't work and generate more data to make it work better on these corner cases, try it again, generate more data, and cycle through this loop very, very many times until we arrive at a solution that is essentially stable, solid, and a product. Using this approach, we build systems that allow, for example, medical staff to control a device without touching, which is important for hygienic reasons. That allows the cars to understand what drivers or passengers are doing in the interior of the car. Or that allows home appliances to be controlled by gestures and to understand what people are doing in the living room. The company was founded in 2015. It's located in Berlin, Germany, and Toronto, Canada. We're working both with enterprises to understand where the pain points are, where the value is, what kind of solutions should be existing that just don't exist without any kind of common sense in these neural networks. We also have a wonderful developer community who's hooked up to our system and using the data sets and exploring use cases that we couldn't even dream about ourselves. Thank you.